Hello students, this video is a quick maths video about one of the questions on the Chapter 7 AP Statistics exam in 2021. The question was talking about, as you can see in the diagram here, it was talking about a high school reunion, and it was talking about the particular incomes of the people that were there. Let's jump into the question. As part of the 25th reunion celebration, the class of 1988, who are all the students that graduated in 1988, at a state university held a reception on campus, and an informal survey. The director of alumni asked 50 of the attendees. Now this is important to note, only asked 50 of the attendees, didn't ask everybody. So we know the sample size is 50 in this case, about their incomes. So the director was able to compute the mean income of those 50 attendees, and we know that mean income is a sample mean income, so we're calling that X bar, to be $189,952. Not bad. In a news release, the director announced that the members of the class of 1988 enjoyed resounding success. Last year's mean income of its members was $189,952. Now notice, he reported last year's mean income of its members. What he really probably should have reported was our sample mean of income from the sample of members that I took, because he's really reporting a population mean. So it's at least worthwhile to point out that this is a population parameter, whereas he's basing it on a sample statistic. For letter A, it says, what would be a statistical advantage of using the median of the reported incomes rather than the mean as the estimate of the typical income? So the difference here that they're drawing, or they're asking about, is the difference between a sample median versus a sample mean. Well, there are a couple of different things that you know about the differences between the mean and the median when it comes to reporting the central tendency of a distribution of numbers. One thing that you should remember about the median is that it's the middle number of a distribution, and it's more resistant, which means it's not as susceptible to outliers. If you had a list of numbers and all of the numbers were in the 50s, and then all of a sudden in that same data set you had a number that was 150, all of the other numbers in that data set would be still around 50, so the median would not be affected. However, if we were talking about that same set of numbers, the mean would be more affected by outliers. It's less resistant because all the average of the values are taken into account, or I should say, all the values are taken into account. So the difference between the median and the mean is that the mean is just less resistant, which means it's more affected by outliers. Why might this be a situation that they come across here? When you're dealing with salaries, it's possible that there's one or two outliers that are very high in the crowd that are much farther than the mean salary than the lower salary. So for example, like if you're looking at this room full of people, you could calculate the mean salary to be $189,952. Now the lowest a salary could be, theoretically, is 0, right? It makes sense that a person may not be at a job, so they may not be earning an income. However, the maximum salary is not an equal distance away from this mean, right? It's not 189,000 times 2, right? The maximum salary could be in the $500,000, $600,000, $1 million range if you're a CEO or if you're a math teacher, for example. So all of those salaries could be much, much larger, much, much farther away from the mean than the lowest salary, which is 0. What that means is it's definitely possible that this distribution of salaries is skewed, heavily skewed, or perhaps just regularly skewed to the right. Since this is probably going to be a skewed distribution, we should be using the median as a measure of central tendency than the mean, rather than the mean, I should say. All right, moving on to section B. The director felt that the members who attended the reception may be different than the class as a whole. Okay, so now we're accepting the idea that the sample of 50 may not be representative of the entire population. A more detailed survey of the class was planned to find a better estimate of the income, as well as other facts about the alumni. So trying to determine whether the sample is indicative of the population. So the staff came up with two methods based on the available funds. Method 1 is going to be sending an email to all of the members, 6,826 of them, and the estimate is that at least 600 members will respond, although they can't really guarantee that. And then method 2, we're going to be selecting a simple random sample. So not all of the members, but only a simple random sample of those. And we're going to contact those members by telephone and follow up to ensure that all responses are obtained. So once we take the simple random sample and look down our list and say, okay, we're contacting all of these people, we're making sure that we get responses from all of those 100 people. We're not accepting, oh, they just didn't answer the phone. We're going to reach out to them with other methods and try to get their responses as tough as possible it may be. Method 2 has only 100 members in it, rather than that 600 member number that they estimated for method 1. So the differences are, method 1, we're estimating that there's probably going to be a lot more people in the sample than method 2. However, in method 2, we're picking 100 people in the simple random sample, but we're definitely going to get 100 people. Whereas with method 1, we're trying to ask 6,800 people, but we're admitting that we don't know how many people are going to respond. Okay, the first thing that you should recognize when we're looking at these two methods is that one of the methods is really a truly random sample, this one, and it is relying on the idea that they're going to get all 100 members to respond. In fact, it's saying, yes, we are going to make sure we do our due diligence to get all 100 members that we selected to respond. However, with method 1, we have a situation wherein if I contact all of these members, the member can sort of choose to respond or not respond. So this definitely indicates or introduces a problem, a source of bias, and that source of bias is, of course, non-response bias. And here's that definition of non-response bias: when individuals don't respond to a survey due to a factor that affects their response. That factor, in this case, I mean, as you can imagine, if you got contacted tomorrow and somebody said to you, what's your income, you might be inclined to answer if your income is something that you want to brag about. However, if you are not employed at the moment, or if you have a fairly low income and you don't really want to reveal that to anybody, you may choose to maybe not answer the phone or not call them back or whatever the case may be. So that non-response bias kicks in. We would assume that, just based on human nature, that the people who are responding to this email are probably the people who want to report their income. And the people who want to report their income, in general, would probably have higher incomes than the folks that don't respond at all. Now, there's definitely a concern with the second method as well. That second method has a much smaller sample size. It's a sixth of the size as the sample size that we're estimating for method 1. However, the idea of making that simple random sample, truly randomizing the members and trying to get a representative sample from the population, and then getting that entire sample to respond eliminates that source of bias, that non-response bias. So even though there is a smaller number of people in the response pool, in the sample, we are assuring ourselves that our sample was obtained in a random way and not being affected by this non-response bias. So hopefully I have argued my point succinctly enough and well enough that I have convinced you that method 2 is probably the better one. Let's take a look at what it should look like. All right, and remember our creed. We must read the question and then answer the question. Which of the two methods would you select for estimating the average yearly income of all 6,826 members of the class of 1988? First, we have to identify which of the two methods we are going to choose. And here we go. We chose method 2, which is preferable to method 1. Make a choice if it asks us to choose. Explain your reasoning by comparing the two methods. Okay, so let's get some comparison words here. In method 1, non-response bias may lead to the sample mean being larger than the population mean, as people with higher incomes may be more inclined to report them. And if we choose method 2, this is getting into the effect of each method on the estimate. If we choose method 2, the sample is truly randomized, and that will create a sample that is more representative of the population than method 1. If you're trying to create a sample that's representative of the population, in general, a good way to do that is to collect a simple random sample. While it is true that the sample size is larger for method 1, we approximate there's going to be 600 respondents for method 1 and only 100 for method 2. Despite that fact, there is non-response bias that makes the data from method 1 less representative of the population. In other words, it's more representative of the folks that have a higher overall salary. All right. That was the video on that Chapter 7 question from the AP Statistics exam. All right, kids, good luck studying.